Alright, so in this video I want to spend some time discussing reaction stoichiometry. That is, the ratios inherent to a chemical reaction. We can actually use those ratios to write some conversion factors. So to elaborate on that, why don't we examine this reaction here, and let's try to come up with some conversion factors to help us solve a couple of problems. So, in this reaction, we're going to take some aqueous sulfuric acid, and we're going to react it with some aqueous sodium hydroxide. And when these two guys react together, we should liberate some water and some sodium sulfate. And here are the molar masses of each one of these compounds involved in the reaction. Notice that for every 1 mole of sulfuric acid, we need to react that with 2 moles of sodium hydroxide. And assuming that reaction goes to completion, we'll get 2 moles of water and 1 mole of sodium sulfate. Now that's one way, sort of one scale that we can look at this reaction. There's sort of another way we could look at this reaction though. Instead of looking at it in terms of moles, we could look at it at a smaller scale in terms of molecules and formula units. So we could say that for every 1 molecule of sulfuric acid, we'll have 2 formula units of sodium hydroxide. And I say formula units because, well, sodium hydroxide isn't really a molecule, it's more of an ionic compound, right? So for every 1 molecule of sulfuric acid, we'll need 2 formula units of sodium hydroxide. And that should produce 2 molecules of water and 1 formula unit of sodium sulfate. Okay, now let's try to come up with a problem. I didn't really have one in mind when I started this video, but let's try to come up with one. Let's say we had 17.684 grams. Yeah, let's say we had 17.684 grams of this sulfuric acid. And let's say we wanted to figure out how many molecules, yeah, let's do that, how many molecules of water we produced. Now, how could we go about doing that? I'm going to implement something called an arrow plan to figure that out. So what we could do is, we could start with the grams of sulfuric acid, and then maybe with this molar mass here, we could convert to moles of sulfuric acid. So let me write that down somewhere. So, grams of H2SO4 to moles H2SO4. Right, so we'll just use the grams they gave us, and we'll convert to moles of H2SO4 using the molar mass of H2SO4. Now, once we have moles of H2SO4, we can use reaction stoichiometry to convert to moles of water. So, we'll go from moles of H2SO4 to moles of water. Now, how do we go from moles of something to molecules of something? Remember Avogadro's number? Yeah, we can actually use Avogadro's number in the last step to go from moles of water to molecules of water. Alright, so we're going to start out with the grams of sulfuric acid, and we're going to use the molar mass of sulfuric acid to convert to moles of sulfuric acid. Then we'll use reaction stoichiometry to go from moles of sulfuric acid to moles of water. Once we're in terms of moles of water, we can go to molecules of water using Avogadro's number. So, now that we have this sort of arrow plan sketched out, why don't we go ahead and give this problem a go. So, We're going to take 17.684 grams of sulfuric acid. And we're going to use that molar mass to convert to moles of sulfuric acid. So we'll put 98.079 grams in the denominator here. And we'll put 1 mole of sulfuric acid up top here. 1 mole H2SO4. Notice that we have grams of sulfuric acid in the numerator over here, but we have grams of sulfuric acid in the denominator over here. Because those units are in the numerator and the denominator, they'll cancel out. So let's go ahead and do that. Alright, so right now we are in terms of moles of H2SO4. I know it's kind of hard to see. My camera isn't necessarily the best quality, but this does say 1 mole of H2SO4. Now in the next step, this is where reaction stoichiometry comes into play. Remember, for every 1 H2SO4 we have, whether it's a mole or a molecule, assuming this reaction here goes to completion, we'll get 2 equivalents of water. Again, whether that's moles or molecules, really depends on which scale you're discussing. Here we're talking about moles. So, for every 1 mole of H2SO4 reacted, we should produce 2 moles of water. So that's going to actually be our next conversion factor. So then we can write, for every 1 mole of H2SO4, we're going to get 2 moles of water. So we'll write 2 moles of H2O. Again, because we have moles of H2SO4 in the numerator over here and in the denominator over here, those units will cancel out. So we'll cancel those out. And now we're left in terms of moles of water. So let's see, the next step we have to do is go from moles of water to molecules of water. We're just going to use Avogadro's number to do that. So, for 1 mole of anything, really, in this case water, you're going to have 6.022 times 10 to the 23rd particles of that something. In this case, we're going to have 6.022 times 10 to the 23rd molecules of water. Alright. And now because we have moles of water in the numerator, and we have moles of water in the denominator over here, our units will cancel out. And we'll be left with units of molecules of water. So, let me grab my calculator here, and I'll punch this in and let's see what we get. So we'll take 17.684, we'll multiply by 1, multiply by 2, multiply by 6.022 times 10 to the 23rd, then we'll divide by 98.079, we'll divide by 1, we'll divide by 1 again, and assuming I know how to use a calculator correctly, which I don't know these days, sometimes I mess things up, we should get a value of 2.172 times 10 to the 23rd molecules of H2O. So let's see. 5 sig figs, 5, 4. Okay, so our answer should come out to 4 sig figs. So this should be right. Alright, so let's just quickly recap sort of what we did here. There was this reaction here between sulfuric acid and sodium hydroxide. Now, when these guys react together, we should get some water produced and some sodium sulfate produced. Then I had the molar masses of each one of these compounds listed here. And I said if we had 17.684 grams of sulfuric acid, how many molecules of water should we produce? So then we came up with this sort of arrow plan, this stepwise plan of attack, really. We're going to start out with our grams of sulfuric acid given to us here, and then we'll convert to moles of sulfuric acid using the molar mass of sulfuric acid. That's what we did here. Now, once we have moles of sulfuric acid, we could use reaction stoichiometry to go from moles of sulfuric acid to moles of water, right? Because for every 1 mole of sulfuric acid, we should be able to liberate 2 moles of water. So that's where this conversion factor came from. For every 1 mole of sulfuric acid, we should have 2 moles of water. Our final step was to go from moles of water to molecules of water. And we did that just by using Avogadro's number here. So then I punched that into the calculator and I got 2.172 times 10 to the 23rd molecules of water. Yeah, I just made this problem up on the spot, so I hope that this answer is right. Yeah, like I said, I've had problems with calculators in the past, so assuming I punched all of this into the calculator correctly, this should be the right answer. Well, there you have it. In this problem, we used reaction stoichiometry to figure out, ultimately, the molecules of water that could be produced. And the reaction stoichiometry really came into play during this step. There you have it. If you have any questions, just let me know in the comments, and be checking the description, because I'll try to put a practice problem in there, and maybe even the answers so you can check yourself. That's enough for one video. Thanks for watching. Stay tuned, because there's more where this came from. And as always, take care.